Okay, we're working from page 306 in the grade 9 textbook. We're talking about solving two-step equations with fractions. We're on page 306 in section 8.2. So the difference between the equations in 8.1 and 8.2 is that in 8.1 we only had one-step equations, and in, well, not one step, but one part in terms of either just a coefficient, I guess, only. And in the second section, 8.2, we have new equations like the one on 306a in the example, 2x plus 1/10 equals 3/5. Now in equations like this, it's no different than the equations you studied in grades 7 and 8. These are two-step equations with a coefficient and a constant. And there's really two ways you can do it. And I'm going to show you both methods, the first one. Method 1 is the same as grade 8. So it's going to be opposite operations. Opposite operations to first get rid of the constant, and then second, the coefficient. All right, so what does this look like? Well, in this particular equation, my constant is 1/10, and my coefficient is 2. And the order of operations in these types of equations is to first get rid of your constant. So I'm going to subtract 1/10 from both sides. Now that's easy on this side because I know that I'm applying opposite operation, and it's gone. And that leaves me with just 2x on my left. But the tricky part is over here. But now what I have is I have subtraction of fractions, which tends to be troublesome for some people for some reason, because adding and subtracting fractions require you to create equivalent fractions with common denominators. So I look at the two denominators, 5 and 10, and I realize that the best denominator I can use will be, or the lowest common denominator will be 10. So I can change this to a fraction expression that subtracts two fractions that have the same denominator. 1/10 doesn't change, but 3/5 will become 6/10. 6/10 take away 1/10. Now that we have same denominators, I keep the top, or I keep the bottom, and I subtract the top, so I get 5/10, which we know reduces down to 1/2. So that's our first step gone. I subtracted the constant from both sides. Now I can multiply or divide both sides by 2. Here I get x. But dividing a fraction by 2 requires me to look at it like this. I change it to multiplication by the reciprocal, which we already had a video on, and I end up with x equals 1/4. Now that's using method 1, which is just opposite operation. And for some of you who have good, strong fraction sense, this might not be a bad method for certain questions, especially this one. It's not a hard one for that. But if I look at, oh, I don't have a back button here. If I look at the second method, 2x plus 1/10 equals 3/5, the second method asks us to kind of have this idea of algebra equations and the fact that the left and the right are balanced, and whatever I do to the left, if I do the same thing to the right, it keeps it equal. So if I was to multiply both sides by a number, I would keep it equal. So if I was to multiply this side by, let's say, 3, and multiply this side by 3, I still keep it equal. And if you multiply it by a different number and a different number, as long as they're the same number, it keeps it equal. So what I'm going to do here is I'm going to put 2x over 1 just to show you that all three terms in my equation have denominators. This one has a denominator of 1, this one has a denominator of 10, this one has a denominator of 5. So if I multiply both sides by a number that is a multiple of all three denominators, the first multiple, then it will work. So I can put 1, 10, and 5. And I'm not going to do 1 because it works with 1, 2, 3. But 10, 20, 30, those are multiples of 10. 5, 10, 15, 20. Those are multiples of 5. And 1, 2, 3, 4, dot, 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 10, dot, dot, etc. Those are multiples of 1. So the first one they share of all the multiples is 10. That means if I multiply both sides by 10, I'll be able to keep it equivalent. Because over here, if I was to multiply both sides by 10, I still keep it equal. So I'm not going to affect it. So I'm going to multiply this side by 10 and this side by 10. Now the problem is, when you multiply the left side here by 10, what we have to see is that the skill I need to have here is distributive property. Distributive property. Because not only do I multiply 2x by 10, but I also have to multiply 1/10 by 10. So I have to multiply both parts by 10. So 10 times 2x, I don't need that 1 anymore, is 20x. That's my first one. 10 times 1/10, well, I can do that over here if I need to. 10 times 1/10, what's that equal? Well, 10 times 1 is 10, and 1 times 10 is 10, so that equals 10 over 10, which is 1. So by multiplying the left-hand side by 10, it was 2x plus 1/10, but by increasing it tenfold, it now became 20x plus 1, no fractions. And by multiplying the right by 10, I get 30 over 5, or 6. Now some of you might be cross-reducing, which means you understand that 10 over 5 equals 2 over 1, and I would have gotten my 6 over 1, or 6, without having to reduce this fraction, so my answer is 6. So by multiplying both sides by 10, I create a new algebraic equation that does not have any fractions, and now all I have to do is subtract 1. I get 20x equals 5. Divide both sides by 20. I get, oh, that's x there. X equals 5/20ths, or x equals the same number I got with my last method, which was 1/4. Okay? All right, let's try some other ones. Let's see how well you do. So we're going to give you an equation. Let's do the show you know at the bottom of 307. So you have the equation 2y plus 1/2 equals 3/4, okay? This is a algebraic equation with a coefficient and a constant. And I want you to try both methods. I want you to try and start your isolation of the variable by subtracting 1/2 on both sides, and then take it from there. And then get your answer. And then what I want you to try is multiplying both sides by what number? You think about what number you want to multiply it by. That's right, 4, because 4 is a common multiple to the denominator here of 1, 2, and 4. The first multiple of those three terms share is 4, so I'm going to multiply both sides by 4. Okay, so press pause, do the work, see if you can do it both ways, and then watch the solution. Okay, welcome back. Here we go. So what we're going to do here is I'm going to first just apply opposite operation by subtracting 1/2 from both sides. All right. By adding 1/2 and subtracting 1/2, I'm left with just 2y. And over here, I have to really think of this as being 3/4 take away 2/4, which is 1/4. So by subtracting 1/2 from 3/4, I end up with 1/4. I'm going to divide this side by 2. I'm going to divide this side by 2. I end up with y equals, can't divide by fractions, so I multiply by the reciprocal, because it was 2 over 1, now it's 1 over 2. And my answer is y equals 1/8. Okay, that's the first method. Hopefully that's what you did for that. Now for the second one, let's look at it if I multiply both sides by 4. So here I'm going to multiply this side by 4, and multiply this side by 4. Using distributive property, I get 4 times 2y is 8y. 4 times 1/2, well, some of us need to think of that, but they know it's 2. But 4 times 1/2, 4 on the top, 2 on the bottom equals 2. Or they cross-reduced, and they also found it was 2. So we have plus 2 equals 12 over 4. So multiply the tops, multiply the bottoms. Or they might have cross-reduced and got 1 over 1 and still end up with the answer of 3. I'm going to subtract 2 and subtract 2. I get 8y equals 1. Divide both sides by 8. Divide both sides by 8. Did I make a mistake here somewhere? I don't think I did. Maybe I did. And you get y equals 1/8. Was that what I got in the last one? I can't remember. Yes, it was. Y equals 1/8. So on both ones, I got the answer y equals 1/8. Okay, let's try that last one that's there. It's b. So it's m over 2 take away 3/4 equals 2 and 3/8. Okay? So I want you to try both methods. The first one is going to be adding 3/4 to both sides and taking it from there to isolate the variable, get your answer. And then I want you to try the whole question again So you're going to add 3/4 to both sides and then work it out to get your answer. And then on the other side, I want you to try it again, write it again, and this time I'm going to multiply both sides by what number? That's right, you're going to multiply both sides by 8. But be careful here because this one, you probably want to change it to improper instead of mixed to start, okay? All right, so give that a go. Press pause, try it out, check your answers, see how you did. Okay, welcome back. So the first thing we're going to try here is we're going to try and just apply opposite operations as if it was a regular algebra problem and just isolate the variable by getting rid of the constant first. So we're going to add 3/4 to both sides. I know that gets rid of my constant and add 3/4 over here. I have half of m left over here. And over here, 16, 17, 18, I have 19/8. Remember I said it would be best to change it over to improper. Plus 3/4 is going to be easier. I'm adding fractions, which requires a common denominator. 8 will be my common denominator, so 19/8 plus 6/8 is the same question. That gets me 25/8. Okay, I added these two. I added the top, so I got 25. Kept the bottom 8. Now I'm not going to change it to mixed right yet because what I want to do is I want to multiply both sides by 2 because I'm not done isolating the variable. I get m over here. Multiply this side by 2. I get 50/8. Now that's my answer. The only problem is it's improper. And because I started with a mixed fraction, it's always good form to put it back to the mixed fraction. How many 8s in 50? There are 6 of them. That's 48. Plus 2 left over. 6 2/8 or 6 1/4. And if I wanted to change that to a decimal, I could. 6.25. That's my answer. Okay, that's the first method. That's using opposite operation and just using algebra sense to isolate the variable. The second method, m over 2, take away 3/4 equals 2 3/8. We're going to multiply both sides by 8. So I multiply both sides by a number that is a multiple of all 3 denominators, in this case 3 because there's 3 terms. And that will give me a new equation without a fraction. So here, m over 2 times 8 is 8m over 2, or 4m. So I get 4m for my first term. Then I'm going to multiply 8 by my second term, because I'm using distributive property. Every term on that side has to be multiplied by 8. So it's 3/4, actually, times 8. Which is 24/4, which is 6. Could have cross-reduced and got 2/1, still got 6. But be careful here, because this is a negative sign, and this is a positive sign here. A positive times a negative is a negative, and that becomes my subtraction. So I get take away 6, or -6. And then over here, I get 19/8. Again, I want to look at it as a improper, times 8. Now, this is where cross reduction really comes in handy, because instead of doing 19 times 8, which I really don't want to do, I'm going to cross reduce this. 8/8 is 1/1. That gives me 19/1, or just 19. All right, so there's my new equation. Add 6 to both sides. I get 4m equals 25. Divide both sides by 4. I get m equals 25/4, which is 6 1/4, or 6.25. Same answer that I got back here. Right, there it is there. Okay, hope that helps. You should be able to do both methods. You should be able to isolate the variable by getting rid of the constant and then following your algebra sense to get to isolate the variable. And you should also understand multiplying both sides by a common multiple to the denominators to create a new equation that is without fractions, right? You're making it that many times bigger so that your terms do not have fractions, okay? If you have any questions, come see me and I'll help you as best I can.